So learning has to be a joyful experience. Enjoy the module. Thank you. Our goal in preparing man BMW Camshaft Less computer control engine familiarization. So what we learned so far? Camshaft is removed, therefore no gear chain, and that is also removed. Gear chain is not required. Fuel pressure booster instead of fuel pump, the fuel pump is removed. Exhaust valve actuator is there, but is operated hydraulically, not mechanically operated. Alpha lubricators are operated hydraulically. Basic principle of alpha lubricators remain same. No starting air distributor, and it is removed. The pilot air is admitted electronically. Pressure measurements are carried out using PMI device for the engine performance. So we have learned that for MEC engine, the component which are removed as component as compared to MCC engine are camshaft with all the cams, chain drive for the camshaft is removed, chain wheel box and frame is also removed, roller guides for fuel pump and exhaust valve actuator also removed, starting air distributor removed. Now some components are redesigned, you can say, like fuel pump. Similar to fuel pump, we have FOPB, fuel oil pressure booster. Similar to exhaust valve actuator, we have exhaust valve actuator, but it works differently. Now, since there is no fuel pump, but FOPB, which is not mechanically operated by hydraulically operated, this means regulating shafts are not required. Because regulating shafts are required to move the rags of the fuel pump. But there are no mechanically operated fuel pump. So we don't need regulating shaft. Exhaust valve actuator is not mechanically operated, hydraulically operated. Mechanical lubricated drive shaft is also removed. There is no drive shaft for lubricator, alpha lubricator, because hydraulically operated. Since no regulating shaft, which were actually operated by the controlled by the governor, there is no governor also. Oh my dear, there is no governor, and can you run the engine? How do you regulate the engine, RPM, etc.? Yes, governor as we know is removed, but the governing functions are carried out. Governing functions are carried out entirely differently. Getting interested? Isn't it? We'll learn it together. So, do we need governing function? Increase, decrease, regulate RPM are required? Of course, we need. Indeed, we require. We need governing function. Therefore, since governor is removed, we carry out governing function differently. Okay? How? That is the purpose of this course. Okay? Now, so now since some new components for MEC engines which are not present in the MCC engine are these are components which are not there in MCC engine, but they are in MEC engine. Since we need hydraulic pressure, we use hydraulic power supply. There is something new. Hydraulic pressure needs to be used for raising fuel pressure and injecting fuel for injecting fuel, and also operating exhaust valve for operating cylinder lubricator, and or of course all this at the precise time required. We have hydraulic control unit, SCU, because the hydraulic power you can create. Power hydraulic pressure is available, but that has to be put to use. What is the entity which puts that hydraulic pressure to use as per our requirement? It is hydraulic control unit, HCU. We will see that SCU. So time when the fuel will be injected in which unit and in what unit and what time. Exhaust valve opened for which unit and what time has to be controlled and managed. Of course, it will be done managed by the engine control system, but actual task will be carried out by the HCU. Because until the fuel hydraulic pressure enters, further action will not take place. So it is the engine control system which directs the HCU to allow the hydraulic oil to go and carry out the function. Because there are no cam plates designed to make fuel pump inject fuel and exhaust valve actuator open exhaust valve at the precise time. ECS must know the position of the particular unit with respect to the crankshaft, isn't it? So unless and until engine control system knows what is the position of the unit piston with respect to the crankshaft, how does it inject fuel? It cannot inject fuel when the piston is midway. It cannot open the exhaust valve when the piston is at the bottom of the cylinder liner. So precise time is required. That is done by the engine control system. Engine control system will tell what time fuel to be injected and what time exhaust valve to open. Accordingly, SCU will allow the hydraulic pressure to move and carry out the task. Any questions? So, to know the position of the particular unit piston with respect to the crankshaft, we have crankshaft positioning sensing system. Since mechanical lubricant shaft drive has no, this is something we'll talk about. Since mechanical lubricator drive, there is shaft is no more there. We have electronically controlled alpha lubricator, operated by hydraulic pressure. We have means of carrying out governor function also electronically and managing starting and stopping of auxiliary blowers. Also the hydraulic auxiliary pump which will be used for generating hydraulic pressure, which will also be controlled by electronic method. Since governor functions are electronically controlled, we have EPIC. We call it EPIC control. What is electronically profile injection control? Actually, continuous control of the fuel injection. Each cycle, when the fuel to be injected from unit 1, so let's say when next unit due for injection, fresh amount of fuel is calculated using a logarithm, okay, which is online continuous control of timing of the fuel injection. Similarly, exhaust valve opening and closing time is controlled by the electro engine control system. Of course, only actuating pressure is hydraulic, but there is precisely controlled electronically. Since fuel injection controlled electronically, where required, amount of fuel injection is calculated by the program algorithm for each time fuel need to be injected. How fast fuel to be injected, how much to be injected, how much pressure needs to be there, pressure intensity of the fuel, the pressure built up. So even at the low loads, 12 to 15 RPM also these engines have been run. In a way, it becomes very useful. Let's say engine is running at 12 RPM, depending on the, of course, size or shape of the engine or number of cylinder, etc. So 12 engines RPM may not move engine even at that slow. So practically, there's no need to start and stop the engine. You stop the engine only if you have to change the running direction. From a low RPM, maybe that slow RPM can be as low as where the engine is kind of standstill. So where are the shuttle tankers? It become very useful. So unlike fixed rate of rise of fuel injection pressure in the mechanically controlled injection, because it depends on the profile of the cam. Here, fuel injection pressure, rate of rise of the injection pressure, and injection intensity is all controllable parameter. That's why we call it EPIC, electronically profile injection control. How fast injection pressure or how slow injection pressure rises are all controlled as per the requirement. As I said, there is very low load running is also very stable operation. So let us see what we have discussed so far. Since there is no fuel pump, but a fuel pressure booster, which is not mechanically operated, but hydraulically operated by SCU. This means regulation shaft is also removed with no fuel racks, etc. There was no fuel rack, nothing to move. So governor, electromechanical governor, as we know, is not there. Exhaust valve or electronic governor, which were certain ships were using with the potentiometer kind of thing, is not there because there's nothing to move mechanically. Exhaust valve actuator is not mechanically operated but by hydraulically operated by SCU as required or desired by the electronic control system, engine control system. Mechanical lubricated drive shaft is also removed. We need something else to make alpha lubricator work. It is HCU which controls fuel injection, exhaust valve actuation, and operation of the alpha lubricator for the cylinder lubrication. So what is HCU and how does HCU look like? So this is an HCU. Example of it. This is actually hydraulic uh, cylinder kind of. We call it fuel pressure booster. This is the one which will allow the injection to take place. When the HCU admit, this is the whole unit is HCU. When the hydraulic pressure enter at the bottom of the unit, then the plunger inside will move up in a kind of a barrel and the pressure will build up. And this is exhaust valve actuator. This also admits when the hydraulic pressure enters here, the time as decided will operate the exhaust valve of the particular unit. Now this is interesting. This is called fever valve. So what is fever? Actually, fever is nothing but FI is fuel injection and VA is valve actuation. Earlier version of the ME-C engine, we had not fever, we had ELFI, 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 and ELVA, electronic valve actuator. So we have two different valves. So when the engine control system send a data or signal to the ELFI, that means electronic fuel injection, it will operate in such a way to admit the hydraulic oil to the unit or the cylinder which requires firing or injection of the fuel. Accordingly, fuel pressure booster will operate and inject the fuel. Similarly, LFI will operate when time comes for the exhaust valve to open for the particular unit. Engine control system will send a signal to the particular FIVA valve or ELVA valve. Now the ELVA electronic valve actuator will allow the hydraulic pressure to enter to the bottom of the exhaust valve actuator, hydraulically operated. And this will move the piston up, moving the oil in the push rod. Conventional engine also we have a push rod which has got hydraulic oil, which has got oil. The oil gets pressed up, it opens the exhaust valve. And this is a kind of distributor which allows the entry of the oil and control. There are certain valves here where you can isolate the respective SU if required, depending on the situation. We'll discuss about it later. And this is called cylinder lubrication. This is alpha lubricator, but it also is hydraulically controlled. But this does not get hydraulic oil for operation from fuel valve, but it has got a different system. It's got a basically solenoid valve and allows the oil to enter. One SU to another SU is connected by the double wall pipe, hydraulic pipe, double valve. Actually, in the double valve, they have got sensor fitted, which are used for alarm purposes. If there is a leakage in the double valve casing, it can slow down also, shut down also. This we'll see later. So let us now introduce some terminology which will be used in camshaft less engine, because certain components are new, the method of controlling is new, so certain new technologies need to be used, and we need to be aware of that terminology. This will also help us understand how the functions necessary for the operation of the diesel engine are carried out without a camshaft, isn't it? So a description of SU and other components is also given below, and explanations in brief we will give as we move upon from the basic function they carry out. ECS, engine control system. So MAN BMW MEC engine control system. Various systems necessary for the operation of the diesel engines are controlled by the engine control system. What is engine control system? Is it actually a window-based software program? Actually, Windows XP system they are using, XP version they are using, not the new Windows 10 or Windows 11 or Windows 7 or Windows 8 something. They're using XP. At the heart is the CPU, computer processing unit. We receive different input-output signal and communicates with other components of the system through data buses. Two computer networks are used. Both networks always accessible and is called always on hot standby. Since actually the many cable you find in the system are not actually electrical, not carrying currents, they're carrying data. So instead of electrical cable, we are using data buses. So a different kind of thought process has to come to the mind of the engineers who are running these engines. That all cables ETO doesn't have to attend, isn't it? Or ETO doesn't have to attend. These are data cables. And the data, the transfer is only restricted. CPU is the fastest actually. Many times is that the delay if occurs is restricted by the type of bus you're using. There are different types of buses, communication buses. You could go through any computer course or information available in the internet. But the data transfer is not restricted by the CPU. Remember that. Data transfer, if any, is restricted only by the data buses used. But in this case, good enough for our purpose. There you can say no delay in transfer of the data. So information is passed so quickly, so quickly, so quickly, beyond understanding. No, I mean you have to believe it. Just to give you an idea, uh, overspeed is almost doesn't take impossible to take place in these ships. More about it later. Okay. ECS requires change of mindset, as I was saying, that many cables used are not carrying current, but carrying bytes, digital data. We need to become tech savvy, yet maintaining our capabilities of a pure marine engineer. Truly speaking, one must be thoroughly conversant and understand the working of a diesel engine to master the concept and functioning of a MEC engine, because parameter can be changed here very easily. You will see later how. You must know what you're doing. On a mechanical engine, conventional engine, you are not changing the position of the cam fitted up for the fuel injection. Yes, timing of the injection you can change, but changing, let's say in a wash pump, changing the shims or removing or adding some certain ship, but you can do that only in a port and time consuming. All right, and you also, but here it's very simple. So when you are doing that changing certain parameter, you must know what you are doing and why you are doing it. isn't it? So knowledge of programming is not required. However, the concept of PLCs, programmable logical controllers, and their functioning with embedded software will help you kind of clear your mind or make your mind, make what to say, make you more mm, computer friendly. Many of you are already computer friendly, but we are not tuned to the controlling our engine with the computer system, computerized system. So that thought process we have to bring into our mindset. Communication and data command signals are not analog signal, 4 milliamps or 20 milliamps or zero point 0.2 to 1 bar, but digital signal, data signal. No doubt, analog signals are also used where required, but most of the work is carried out by bytes, data signal. All this cable must naturally, cables need a screening. A screen has to be there. Screen not like a piece of plastic or something. It is in the cable which is passing through a screening cable is, if you have seen, is placed, which is an essential part of the design as a communication cable. The screen shields for electromagnetic disturbances and emission, which can disturb your data also. Okay. For example, taco system we are not talking much about. I just told you there is a crankshaft system, sensor system, where we know the position of the engine unit with respect to crankshaft. That we'll talk little later. So here you see some of the components of the ECS, engine control system, are EICU, ECU, CCU, ACU, MOP, LOP, and TAGO system. So all of these are new terminology for marine engineers. All right. Just very briefly, very broadly, very simply speaking, bridge control, bridge system. We have main operating panel, which is there in the control room. We have EICU A, EICU B. EICU is what? Is engine interface control unit. Engine interface control unit. As the name implies, is you remove I from EICU, what become ECU? ECU is engine control unit. So by putting I, making it EICU is engine interface control unit. Basically, what we have done, it's an interface between the engine control system, engine control unit, with remote control system, that means bridge control, also engine control, safety system, and alarm system. Safety system, alarm system, and remote control system is not provided by the MAN BMW. It is provided by third-party suppliers like Kongsberg, Linksbo, or AutoChief. So their interface with the engine control unit or engine control system is EICU, engine interface control unit. All right. A and B are the networks. A and B are the networks. So EICU and EICU-B will be connected to MOP and also to the other controllers of the system in the engine control system. EICU-B, A and B. Here MOP and PC. Here just it will be sufficient to say that there are two MOPs, one MOP and other MOP, just like a PC, normal standard PC. I think this will suffice for the time being. We'll discuss it and learn about it more as we go forward. Then we have a local control panel. All right. So local control or local operation panel, we do not call it local control panel, we call it local operation panel. So it can be considered as a local stand which we have in conventional engine. Now, the engine control unit, ECU A and ECU B, which is there in the engine room, is actually connected to LOP. It's the ECU which carry out all the function of the running of the engine. All right. So it is connected to the engine control unit, local operating plan. No doubt, EICU is also connected to the both the ECUs, A and B. All right. And they in turn connected to CCU and ACU. ECU A, engine control unit A, ECU B, engine control unit B, again same. Connected to two network, always hot standby. One is used, other one in hot standby. When it changes over, nobody knows, because it's certain data may be transferred by this, by that, ECU A or ECU B, always working in conjunction. ACU is auxiliary control unit. As the name implies, the auxiliaries are controlled by the ACU. ACU. What are the auxiliaries? We have auxiliary blowers. Also, in this case, we have hydraulic pumps. There are two types. We'll talk more: engine driven and electronic driven, which are controlled by auxiliary control unit. Then we have the CCU. CCU is one for each unit, cylinder control unit. So actual function of a cylinder are carried out by CCU as directed by the ECU. Brain behind that is ECU, but the brain behind, like, is chief engineer, and the actual work is carried by the second engineer or first engineer, what you call, something like that. So CCU is basically fuel injection, exhaust fuel actuation, cylinder lubrication, and a starting air valve. So four functions are carried out by the CCU. Okay, fuel injection, exhaust fuel actuation, cylinder lubrication, and also the starting air valve opening whenever required, whichever unit due for receiving air as per the position of the unit running direction, as a desired running direction. All right.